Hi everyone, welcome to the solution video for the second problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. So as you can see, I have my sheet right here and I can open my question. So the problem is called grouping increases. You are given an array A of size n. You will do the following operations to calculate a penalty. Split the array A into two subsequences, they can be empty also, S and T, such that every element of A is in either S or in T. For an array B of size m, define the penalty PB of an array B as the number of indices I between 1 and m minus 1 such that Bi is less than B of I plus 1. The total penalty you will receive is PS plus PT. If you perform the process optimally, find the minimum possible penalty you will receive. Okay. So in this problem, what we have to do is that we have been given one array, okay, of size n. So we have been given a1, a2, a3 up to an, okay, and we have to basically split this into two arrays s and t, okay, and like every element has to be an element of either s or t, not both, right? And also the order can't be changed, their relative order can't be changed, and that's what a subsequence is, right? So that's what they're saying, that every element should be either in S or T, and we have to like split them in such a way that the penalty, like penalty of S plus penalty of T, should be minimized. And what is penalty? So penalty for an array S or T, let's say for S, if we are calculating, then penalty for array S is the number of indices I such that S of I is less than the next element S of I plus 1. Okay. So let's look at samples now. So this first sample is like 1 2 3 4 5. So what we can do here is that here, okay, so the array is given to be 1 2 3 4 and 5. So let's see, like let's say we split this S, like we set S as 1 3 and 4, okay, just arbitrarily 1 3 and 4, and T as 2 and 5. If we have set S as 1 3 and 4, of course we have to set T as 2 and 5, right? So now if we calculate the penalty for this, the penalty for S, what it would be? It would be this index, like these two indices don't follow the rule, like S of I is less than S of I plus 1. So we have one penalty from right here and one more from right here. So we have 2, and P of T is equal to 1, right? There's only one index, that is not satisfying. And so finally the answer is 3. And this division that I did is optimal. Like we cannot get any answer less than 3. That is 0, 1 or 2 we cannot get in this array, and I'll prove that while telling the solution, right? So the answer is 3 to this. And similarly you can try out these other samples for yourself, okay. And the n in this case, n is up to 2e5 and the elements are up to n, right? So the n is up to 2e5. So basically, since in 1 second you are allowed to do 10 to the power operations, so if you have like 1 second only, then you can only do 10 to the power operations approximately. So if n is up to 2e5, then O of n square would definitely not pass. So you have to do like O of n or O of n log n, right? And that is the expected time complexity. Like it might be one of these or it might be something else also, but these are the most common ones, and definitely not O of n square because it won't pass. Alright, so now at this point you can try and solve the problem by yourself. Okay, so I'm assuming that you have tried the problem by yourself and now you want the solution. So for the solution, what you have, like basically first I'll tell you a nice way to look at this problem, and then we will solve after that. All right. So what the problem says that we have an array a1, a2 up to an, and we have to split this into two sequences, right? S and T, such that every element is in S or in T of AI, but not both. So basically, you can think of it like you are iterating through this entire array. Like, let's say you are iterating through this array, and for each element, you have to keep it in either S or in T. Right? You have to make one choice. Either you can keep in S or you can keep in T. You have two choices. Right? So let's say you keep this A1 into S. Then you go to A2. So let's say you keep A2 also into S. Then let's say you go to A3. Then you keep A3 onto a T, and so on. If you do this process, and like if you choose at each step that in what array do you want to put that element, then you will get a subsequence of S, like subsequence S and subsequence T, such that every element is there in either S or T, right? So basically, instead of just thinking that you are choosing some elements like this and keeping them in S, you can think of it like you are basically starting up with S and T initially empty arrays, and then you are iterating through the array, and for each element you are pushing it either to S or to T. Okay, so we will follow this model of thinking, right? So what you have here is S and T, and also an array A that is given to you in the input. So A1, A2 up to AN, and your S and T arrays are initially empty. So what you can do is you can push back elements into them, right? Now one claim that I have here is that only the last elements matter. Okay, so what I am saying is that only the last elements of S and T, like whatever is currently at the end in S and T, only that matters. Okay, so let's say, for example, if I have this array from A1 to AN, let's say I have inserted this A1 in here, A2 here, A3 here, A4 here, let's say, then A5 here. Then now I want to insert A6, right? So, okay, now we have inserted A1 to A5 and A3 to A4. Like basically A1 to A5 we have inserted, A1, A2, A5 we inserted in S, and A3, A4 in T. And what we have to do is calculate the penalty, like for a total array, right? So let's say that until here we have already found the penalty for these 5 elements. Like we have checked whether these two pairs are their consecutive one, like is A1 less than A2, and we have checked that is A2 less than A5, and we have checked that is A3 less than A4. Like the penalty for these 3 pairs has been calculated, okay, already. Now if we want to insert one more thing like A6, okay, so either we will insert A6 into A5, right, or we will insert A6 into A4, I mean into T or into S. So if you insert A5, like A6 into here, then you will compare A5 and A6, right? And if you insert A6 onto this array, then you will compare A4 and A6. So in either case, the value of A1, A2 or A3 doesn't really matter. Only the last elements that are currently in your array in SNT, only they matter for your decision of where to put A6 into S or into T, right? So basically your current state of SNT can be only defined by the last elements. Okay, like you can simply define your state, I mean not a DP state, but like you can identify the arrays SNT just by their last elements, because that's what matters while inserting one more element, right? So only the last elements matter, right? So you can think about this, like just pause the video for a bit and think about this. Now yeah, that is one claim. So basically we can just make the cases for the last element and then we can solve the problem. Like we can simply do some casework of where like what is a6 and with respect to this last elements. Okay, so let's say in general, if I see that, okay, let's say we have two arrays s and t. So in s, let's say we have inserted already some elements a1 up to x, like the last element is x in the s array, and in the t array the last element is y. Okay, so we have inserted something and last element is y, so only the last elements matter to us, obviously. So let's say in the s array the last element is x, the t array last element is y, and we want to insert a of I. Like basically we have inserted all the elements from 1 2 3 up to a of I minus 1, and now we want to insert a of I. Okay, so let us make some cases. All right, so let's say that case 1 we have that your a of I is less than equal to both x and y. Or actually what we can just do to make our lives easier, we can assume that here x is less than or equal to y, like the value of x is less than equal to value of y. We can do that because these two arrays are symmetric. Like what's the difference between s and t? S and t are but the same. So let's say that if the value of x was 4 and value of y was 3, then x is not less than equal to y. But in that case, we will just call this array as s and this array as t. It doesn't matter, right? We'll just swap those two arrays. So instead of assuming the general case, we can assume that x is less than equal to y. Okay, so on the number line, we have x less than equal to y. Alright, so ai can be either in three ranges, like either ai can be here or here or here. Okay, so let us take these three cases one by one. So the first case is when ai is on the left side, that is ai is less than equal to x. Okay, so in this case we had that the last element is x in s and in t the last element is y, right? So you have two options right now. Either you can put ai right here or ai right here. Now since we know that ai is less than equal to both x and y, like this is the following condition, so definitely wherever we put ai we will not get a penalty, right? That is pretty clear. We won't get a penalty because for us to get a penalty x should be less than ai, and that is not the case, or y should be less than ai. So in both the cases we won't get a penalty, right? So how do we actually decide that where should we put it, like where should we put our ai? Now that boils down to what your objective is. Your objective is to minimize the total penalty. Like what you are right now doing, like your decision to put ai right here or right here might affect that in future you get penalty or not. And since you want to minimize the total penalty, you have to take care of future as well, like you have to think about the future as well. So even though in both the cases you are not getting any penalty right now, but it might happen that one case is worse than the other. Okay, and that's what I'll show you. So let's say we put ai into this array, ai as x. So then after I put this ai, for the next step what is my state? Like for the next step I have ai and y as my state, right? And if I put ai into this t array, then on the next state I have x comma ai as my state. So basically after putting ai either here or here, these two are the possible states that I can reach, and in both the cases I won't get any penalty, right? So which one is better? Let us think about that. So see, when I try to insert one more element, let's say in the future when I try to insert some aj, like I'll take an example, like for example if I decided to put ai here, and in future let's say I decide to put some aj right here, I mean not like this, just after this, like basically I put all of the elements from I plus 1 to j minus 1 into this array, and then aj into this array. Okay, so in that case I will get the penalty. I'll get the penalty if aj is greater than a of I, right? So that means that if my a of I is large, like if I keep my ai as large as possible, or basically not a of I, basically the last element of my array. Like if I keep my state, the last element of my array, as big as possible, then it is less likely that AJ will cause a penalty, because we will get a penalty if AJ is greater than AI. So if we have two options, either to keep 3 or 5 as the last element, then we'll definitely keep 5 as the last element. Why? Because if 4 comes, let's say in the form of AJ, then if we have 3 as the last element, then we'll get a penalty. But if we have 5, then we won't get a penalty. Okay. So that is the entire idea, that we need to maximize our state. So in one case, like one option we have is AI comma Y, and one is AI comma X, right? So in both, AI is the same. The difference is between X and Y. So we want to keep the higher one of them, right? Our state should be as high as possible to avoid any penalties. So simply what we can choose is we can choose the Y, because Y was the higher one, as you can see right here. So basically in this case, we will insert into S. Alright. Now let's take this case, that where AI is greater than Y. Okay. Because it is very similar. So case 2 where AI is greater than Y. So we have S, which has the X as the last element, and T, which has Y as the last element. And let's say AI is greater than Y, so it means AI is greater than both of them, right? So if we put AI right here, or if we put AI right here, then in both the cases we'll get a penalty, because X is less than AI and Y is also less than AI. So in both the cases we'll get a penalty of 1. So where should we choose to put it? Now the thing is that the same thing happens here. Like if we put AI into this array, then our state will be AI comma Y. And if we put into this array, then our state will be X comma AI. And the better state among these ones is AI comma Y, because I showed you right here that in the future it is more likely to get a penalty if our AI is less, or our state is less. Basically this X is less than Y, right? So if we choose to keep this X, then we might get more penalty as compared to this Y. Like this Y will definitely not give more penalty than X, that is for sure. So we can keep this Y, like basically we can insert AI after X. So essentially we are keeping a Y. So in this case also insert AI into X, right? And the third case that we have, is basically in between. Like if AI is greater than X, X is less than AI, but it is less than equal to Y. So basically we have S right here, which has last element as X, and T right here, which has last element as Y. And we put AI either here or here. So if we put AI here, then we'll get a penalty. And if we put AI on Y, we won't get a penalty, right? So in this case 1 penalty, in this case 0 penalty, right? So some of you might think that definitely we should put AI into the Y, because we are not getting a penalty here and we want the minimum penalty. So we'll just put AI right here. But there is an issue with this, because it is possible that in future you might be messing up your state. Like see, if you put AI after as X, then what is your state? The state is AI comma Y if you put in S, and if you put in T, your state is X comma AI if you put in T. So as you observed that if you put in S, we get a better state, right? This AI comma Y state was better than X comma AI for the future, right? But on the other hand, choosing this state will not get us any penalty. Like it will give us only 0 penalty. So we have a dilemma here, that should we prefer less penalty, or should we basically prefer a good state? So the answer is that less penalty should be preferred, definitely. Like if you get 1 penalty or you get 0 penalty, you should prefer 0 penalty. Okay. And the proof of that, like this is a greedy approach, basically. Greedy approach, and its proof is as follows. Like the proof is quite interesting. Like what you can simply observe is that, let's say I have two cases, right? I have two cases. One, I can put it into S, or two, I can put it into a T, right? So right now I have X as the last element and here Y as the last element. And if I put it into S, then AI goes right here. Okay, and if I put it into T, X and Y, and if I put it into T, I have AI right here. Okay. Now let's say that in both the cases, I put like A of I plus 1 up to J minus 1. Like, let's say that I also put A of I plus 1 up to A of J minus 1 in the same array as the X, or as the AI, I mean. Okay, so in this case also, we keep basically A of I plus 1 up to A of J minus 1 in the same as AI, right? So, okay, first of all, since we had put this AI into X, in this case, we already have gotten one penalty, right? One penalty already we have gotten because of this. And in this case, we haven't gotten any penalty. So, zero penalty we have gotten, right? And now we are comparing these cases for the future. Like in the future, if this happens that up till A of J minus 1 we put right here, and then A of J is the first index that we put in the opposite one. Okay. So my point was that, okay, the penalty due to these indexes from A of I plus 1 to J minus 1 are same for these both, right? And as soon as we put A of J after X and Y, the state becomes the same. Like the state now after putting A of J is the same, AJ plus AJ minus 1 and AJ, and AJ minus 1 and AJ, right? So we just need to consider the penalty for these two, right? So in this case, since we know that X is less than equal to Y, okay, so basically since we know that somewhere X is right here and Y is right here, so if this were the case and AJ turned out to be here, okay, then in this case we would not have gotten any penalty because this is the condition, right? AJ is less than equal to Y. But in this case we would get a penalty, right? Because X is less than AJ. So until now we have gotten one penalty here due to this, and one penalty in this case due to this pair, right? But you remember that we didn't get any penalty right here. Like when I inserted this X AI into X and AI into Y, this was no penalty and this was one penalty, right? So if I get penalty right here but not here, so that is just compensating. Like until now we have 1 and 1 in both of them in the case where AJ is between X and Y, right? But what about the other cases? Like what if AJ is less than both X and Y? So if this is the case that AJ is less than both X and Y, then basically I won't get a penalty in both of them. Like this Y greater than equal to AJ is there, and also X greater than equal to AJ is also there. So I won't get a penalty in both of them. So essentially I have gotten a profit by using this case, because initially also I didn't get any penalty because I chose AI comma Y. Like I chose to pair it with Y, this AI, and in the future I don't get any penalty. And in the worst case also, if I get a penalty, I get only one extra in this case, so it balances out, right? So basically if I choose this case, either my penalties balance out, that is this cancels out, or I am in profit. So definitely choosing this case is more profitable to us. That is, choosing the zero penalty case is more profitable to us, right? So you might want to repeat this video part 2 or 3 times to understand this. It is very crucial. Okay. Or you can pause the video and think about it yourself. That is also very helpful. Alright. So that was the entire greedy proof. So the greedy was that we choose the one with the lower penalty, and it is proven that since we are at one profit here, one penalty profit, and because of this decision that we are choosing a worse state, like this state is worse, right? So due to that decision, we can only be affected by one penalty. Like we can only have a loss of one penalty in the future, and that can be covered by this penalty right here. And in case we don't get a loss in the future, then we are very happy because we gained a profit of one by choosing this thing right here, right? So that is the entire logic, that if your AI is between x and y, then just put it put AI into your t, right? So for the first case, put AI into s. For second case, put AI into s, and for third case, put AI into t. And finally, just find the penalty, right? And while implementing this, you can simply store the last elements of s and t. Like no need to store the entire s and t arrays, just store the last elements of s and t. Okay. And yeah, so here if I give an example, like we have, let's say we take this only 1 2 3 4 and 5. And okay, initially you can assume that this s and t has infinite as the first element, because when you insert the first element, you can never get a penalty because of this, and that's what this achieves, right? So let's say you insert 1 into here, then you will insert this 2 where? You'll insert 2 into here because it is case 2. Then this 3. Now we have a case 3 basically. So we will insert it into 3. Then again we have a case 3, so we'll insert 4 into here. And also again we have case 3, so we'll insert 5 into here, right? So that is how it works on the sample. And as you can see, the penalty is just 0 for this one and 3 for this one. So the penalty is 3. All right. So now let us look at the code. So in the code, I have this fast IO and the test cases. And in the main solve function, I have int n, cin n, take the input. And I have 3 variables, answer variable and x and y. So I'll iterate through the array. And since I assume that x is less than equal to y, I'll just swap them if x is greater than y at any point. So now the first case is that if ai is less than equal to x. So in the case 1, we insert ai into s. So now the new value of x is equal to ai. Otherwise, if x is between, like ai is between x and y, then it is case 3. And in that case, we insert into t. So y is equal to a of I. And otherwise, it is case 2. So we insert it into x and our penalty increases by 1. Right. And finally, we just output the penalty. And the tease of this approach is O of n, because we have this O of n loop, right? And we are only using O of 1 extra space, just these 3 variables. So it is O of 1 space, right? So the TC is O of 1 and SC is O of 1. All right. So I hope you understood this, and thanks for watching.